class. This week we're going to be focusing on the topic of interfaces. Interfaces show up everywhere in Java, so it's extremely important that you understand what they are, how to write them, how to use them, etc. And to motivate the idea of interfaces, I'd like to talk a little bit about air traffic control. So you've probably already seen this in the lecture slides, but in air traffic control, a controller will usually bark out commands at aircraft of what he or she wants that aircraft to do, such as, I want you to take off, I want you to land, I want you to change your altitude, change your heading, etc. And any aircraft that are flying in the sky, regardless of whether they are, say, an airplane, helicopter, or even a blimp, must be able to obey those directions. So the directions that ATC is providing are generic in the sense that they apply to any aircraft type. So for example, if I ask an airplane to take off, well, the airplane will take off, but the way it does so is very different than, say, the way a helicopter will take off. So an air traffic controller will ask an airplane or a helicopter or any other flying object for that matter to take off, and that particular aircraft type will perform its own procedure to take off. And again, the way an airplane takes off is very different than the way a helicopter takes off. So to build upon this example, I want to create a Java project with actual code to demonstrate the use of an interface. We're going to create an interface called Flyable, which consists of a couple of commonly used air traffic control commands. And any aircraft type that we want to implement after that, so let's say we want to write an airplane class, a helicopter class, etc., needs to implement this flyable interface. So to that end, let's go ahead. We're going to create a new project in NetBeans. I'm going to go to File, New Project. I'm going to select a Java application, click on Next. The project name will be Flyable. The main class will be Flyable Tester. This is where I'm going to have a main method to test everything once I'm done. I'm going to click on Finish, and this will create a new project for me. Now, I'm not going to worry about this tester class yet, but I do want to create a new interface. So I'm going to go to File, New File. Now, instead of Java class, I'm going to select Java Interface. You could choose Java class if you want, but then you'll just have to change the word class into interface later on. I'm going to click on Next, and I'm going to call this interface Flyable with a capital F in front. So I'm going to click on Finish, and here is my Flyable interface. Let's remove some of the comments for now. And I want to define a set of methods that any class that's implementing this interface Flyable must provide implementations for. So in this case, we can think of this, the analogy of air traffic control. We can think of the common commands that air traffic control will ask aircraft to perform. So there are many of these. Let's just select two of them. The first one is going to be a takeoff procedure. So I'm going to just list methods. This is very much like a C header file. We're just listing methods here. So let's do void takeoff. This is a method that any aircraft, regardless of whether it's an airplane, helicopter, blimp, etc., should be able to implement. And let's pick another method. It's going to be called void yieldWay2, and it's going to take one argument of the type Flyable. So when you see a reference type that is of an interface type, a reference to an interface type, what that means is that this reference right here can point at an object of any class as long as that class implements the flyable interface. So later on, as we will see, this reference F can point to an airplane object, it can point to a helicopter object, it can point at whatever, as long as that whatever implements the interface flyable. So we're going to write a very simple interface. It contains two common air traffic control instructions: takeoff, yield way to. If you want to be more exhaustive, you could write land, change heading, change altitude, say altitude, change speed, whatever. But to keep it simple, let's have two of them. Otherwise, we'll be here all day. And I want to keep this video short and sweet. So let's go ahead and write a class that correctly implements this interface. Let's begin with the first natural flying object we think of, which is an airplane. So I'm going to go to File. I'm going to select a new file. I'm going to create a new Java class. Click on Next. I'm going to call this class Airplane. So we're going to write a source file called airplane.java. Click on Finish. Let's remove the comments for now. Now, in order to declare that our class implements the flyable interface, I need to add the keywords implements flyable into our class header. And as soon as I do that, you're going to see an error pop up. And if we highlight the error, it says airplane is not abstract and does not override abstract method yield way to flyable in flyable. So translated back into English, what this means is that we've declared a class that implements the flyable interface. However, we have not yet provided implementations for the two methods listed in the interface flyable. So we need to do that, and we'll get to that. So let's start writing an airplane class, just as if it were any other class. Let's define some fields. So let's try private int, or it'll be a string because this is going to be a tail number. But tail numbers sometimes have letters in them, so we're going to make this a string. We can add some other fields. I'm not going to really use them here. You could add like private double airspeed and things like that. But let's just keep it simple. We just want a simple class that correctly implements the interface. So an airplane has a tail number. Let's go ahead and implement our flyable methods. So the first one was public void takeoff. And the implementation, if you're really writing a takeoff method, you would have to talk about flaps and throttle settings and gear settings, etc. But just for simplicity, the implementation is going to be something very simple. Just system.out.println airplane plus tail number is taking off. So there we go. Let me move this to a second line. That's our takeoff method. By the way, we also want a constructor for airplane. So we want public airplane. Let's give it a string tail number, and I'll put an underscore in front of it so we know that this is a local variable. And we'll simply set tail number equal to whatever we pass into this function. That's our constructor. And then the next thing we're going to do, okay, going back to our takeoff method, so we see that there's a warning. If we highlight the warning, it's requesting that we add the override annotation. You don't have to, but to suppress the warning, it's a good idea to do so anyways. And once you do that, next to the takeoff method, you'll see a green circle with an eye on top. And if we hover over it, it says that this method implements a method from the flyable interface. So are we done? The answer is no. Of course, we also need to provide an implementation for yield way to. So let's do that. At override public void yield way to flyable f. So we need to provide an implementation here. So this is, again, going to be a very simple implementation. System.out.println airplane plus tail number. And actually, I'm going to show you a little shortcut for doing this. I'm going to write this. And you're wondering, why am I writing this? Well, first of all, what is this again? This is a reference to the aircraft that's going to be yielding the way to F. So what does it mean to print line? Well, if we print line and reference that object, what's going to be printed out is the output of the toString method. So we talked about this last time. The toString method returns a string representation of an object, and so we're going to have to provide an implementation of toString shortly. Is slowing down and let's add a plus, yielding the way to plus F. Alright, so this is the implementation for yield way to, and it's correct, doesn't need to return anything. And now, just for fun, let's define a method that only applies to airplanes. So let's write a method called public void stall recover. So when an airplane gets too slow, what happens? It enters what's called a stall when the wings loses the lift, which doesn't get created unless the airplane is moving fast enough. And when the airplane slows down too much, well, I don't want to get into the science of it, about angle of attack and all of that, but let's just say it's not good. So if an airplane starts moving too slow, slower than the stall speed, it's going to stall. So we're going to write a method called stall recover, which will describe the procedure an airplane will execute if it does enter a stall. Usually it's to pitch the nose down and speed up. But our implementation here will just be a print statement. System.out.println. This is recovering from a stall. Alright. So this is a method that is unique to airplane that's not listed in the flyable interface. And lastly, I want to override the method toString. So you might wonder, well, what are we overriding? Why am I putting an override annotation? There is no toString in flyable. Well, technically there is, because remember, toString is a method defined in the Java object class. And every subclass of object, which is any class, in particular, even classes that implement flyable have access to toString and have the ability to override toString so that we can customly define the string representation of any object type that we create. So for toString, what do we want to do? We simply want to return airplane plus whatever the tail number is. So here's our toString method. Alright. So this is a simple airplane class. Now what I want to do is I want to create another class that implements flyable. I want to create a helicopter class. So I'm going to go to File, New File. I'm going to select Java Class. I'm going to click on Next. I'm going to write helicopter. Okay? Click on Finish. Let's get rid of some of these comments. And just like we did with the airplane class, I'm going to declare that my class helicopter implements the flyable interface. Okay, well, we get an error, of course, because we have not provided implementations for the flyable methods. So let's go ahead and add some fields. Just like the airplane class, helicopter is going to have a field called tail number. So private string tail number. We can have some additional fields, some that are specific to helicopters, such as rotor speed and things like that. but I don't want to worry too much about that right now. You can add that at your own leisure. Now let's go ahead and define a constructor for helicopter, public helicopter string tail number. And this is basically the same exact constructor that we had for airplane. That doesn't really matter. That's not important to this exercise. What is important is how we override or provide implementations for the flyable methods. So at override, public void takeoff. This is the first of the two methods declared in the flyable interface. And the implementation will be simple, system.out.println, much like we had in the airplane class. We're going to just print that the helicopter is taking off. So I'm going to write this. Is taking off. And I'll write using I'm going to say vertically. Since a helicopter technically can take off vertically, although they try not to do it very often, technically it can. It's taking off vertically. I just want to provide some implementation for helicopter that's different than airplane. Now I'm going to override the other method. Public void yield way to, and we need a reference to some flyable object f. And the implementation will be simple, system.out.println. This is slowing to a hover in order, actually let's separate this into two lines. Can't seem to spell today. To avoid, plus we'll call the toString method of f. So notice that yield way to has a different implementation for helicopter than it does in airplane. And lastly, we can define a method that is unique to helicopters. So let's do at override, or no, we don't need it at override, I apologize. Public void hover. And the implementation will be system.out.println. This is hovering. It's hovering 1 hour or 2 hours. I don't know. It's not important to this exercise. And lastly, I want to override toString for the helicopter class. So at override public string toString, and implementation will be return helicopter plus tail number. Alright, so here's our airplane class and here's our helicopter class. Both of them correctly implement flyable, and now I want to write some kind of test function that'll test the use of helicopter and airplane. So we're going to write a main method. So look at the interesting ways that we can use to create helicopter and airplane objects. If I want to create an airplane object, I can write airplane A equals new airplane, give it a tail number like N1234. That's November 1234. Using the phonetic alphabet for the N, which is typical in aviation. Airplane A equals new airplane. That's one way I can create a new airplane object. So Everything to the right of the assignment is the object creation. I'm creating a new airplane object with tail number N1234. And what I'm assigning to that, which is everything to the left of the assignment operator, is a reference of type airplane. So notice, we're creating an object of type airplane, and we're assigning a reference of type airplane to that object. Observe how I'm decoupling the object from the reference. This is important, because this sort of thing comes up all the time when we start talking about inheritance and polymorphism. The object type and the reference type don't necessarily have to be the same. Now observe. Since airplane implements the flyable interface, you can in some sense think of airplane as being a subclass or a type of flyable. So you can choose the reference to that object to be a more generic type. So we can take a flyable reference and point it to an airplane object. The only rule here is that the reference type must be more general than the object type. So we can use a flyable reference to point to a new airplane object. Now also, keep in mind that we mentioned that in Java there's a cosmic superclass called object. And every class in Java is a subclass of object. And so object is, of course, always more general than any type. And so if we want to, we can make this object. But the limitation here is if we make the reference type object, well, the reference will not know anything about what it's really pointed to. It won't be able to call any method specific to airplane. If we want to be able to issue air traffic control instructions, we really need to keep this as a flyable reference or better. However, if we're more specific than flyable, and we make it airplane, then we can't point at any helicopter object. You see, we can use a reference type flyable to point at any object of any class as long as that class implements the flyable interface. Okay, very good. So let's do the same thing with helicopter. Flyable H equals new helicopter. We're going to make this November 5678. And now let's call some methods. A dot takeoff, H dot takeoff, and let's make the airplane yield the way to the helicopter. H. Now notice, by the way, that this works, this last statement works, regardless of whether this is flyable or helicopter. So for the sake of argument, let's keep it helicopter. So A dot yield way to H. H can be a reference of type flyable or reference of any class as long as that class implements flyable. So we're issuing an instruction that the airplane must yield the way to the helicopter H. Now let's say it did that and the airplane slowed down, and the airplane slowed down too much to the point where it stalled. Well, it needs to recover from a stall. So let's say we did A dot, what do we call that method? Stall recover, I think? Yes, stall recover. A dot stall recover. But as soon as I do this, you'll notice that there's an error that pops up on the screen. What's wrong here? Well, if we click on it, or we hover over it, it says cannot find symbol. We cannot find a method stall recover in the reference type. So the reference type here is flyable. Now, even though there's a method called stall recover in the airplane class, the reference to the airplane object is actually of type flyable. And so the only methods that the flyable reference is going to see are methods that are listed in the interface flyable. But if we look at the flyable interface, there are only two methods, takeoff and yield way to. So what this means is that we cannot use the flyable reference type to call a method that is specific only to the airplane class and not listed in the interface. So what do we do? Well, if you happen to know that the flyable object is actually pointed to an airplane, what you can do is you can typecast since we know we're pointed at an airplane object, we can take our reference A, we can typecast it to airplane, and then we can call stall recover. Now let's go and run this project and make sure that everything works like it should. I'm going to go to Run, Clean and Build Project. Build successful, run project, let's see what happens. Okay, the output is as follows. Airplane N1234 is taking off. Helicopter N5678 is taking off vertically. Airplane N1234 is slowing down and yielding the way to helicopter N5678. And lastly, airplane N1234 is recovering from a stall. So very, very good. Alright, so everything worked as it should, and notice that whenever we use this reference type, so A and H, let's go back to the case where both are flyable objects, flyable A and flyable H. Notice that if I rebuild it, the same thing is going to happen. This is not going to change anything here. So even though this reference is of type flyable, A is pointed to an airplane and H is pointed to helicopter, and we're calling takeoff. But notice that even though the method is the same exact name for both the airplane reference and the helicopter reference, both of type flyable, a completely different implementation of takeoff is executed depending on the underlying aircraft type, whether it's airplane or helicopter. And so we can see that we have a form of polymorphism here. We have the same name, takeoff, calling two different implementations depending on whether the underlying type is airplane or helicopter, even though the reference type is the same, flyable. So this is polymorphism. This is what interfaces allow us to do. Now I'm going to try something else. What if I try to do this typecast on H instead of A? So recall that flyable H is pointed to a new helicopter object. What I'm trying to do is take H, which is a flyable reference, and typecast it to airplane, so I can call an airplane method, stall recover. Well, one might immediately think that this code will not even compile. I mean, we're pointed at a helicopter object, right? But I'm not seeing any red underlines. There's nothing here that the compiler is complaining about. In fact, if I go to run and I clean and build the project, it builds successfully, compiles without any issues. So what gives? I mean, something seems wrong here. Well, let's see what happens if we try to run this. If I run this project, we get some red writing. And we can see somewhere within the red writing, exception in thread main, java.lang.classCast exception. A classCast exception is thrown. What does that mean? Well, this is the error that corresponds to what we just did wrong. We're trying to take a reference that's pointed to helicopter and typecast into airplane to an invalid class, to an incompatible class. And therefore, we get what's called a classCast exception thrown. We can't do that. And so it is an error, but it's not a compile time error. It's actually a runtime error, because this resolution of what method to call and what the underlying object is, this is something that happens at runtime. It's not something that happens at compile time. So you have to be very, very careful about this. Okay, so one way to make sure that you don't run into this problem is Java has a method called instance of. So watch what I'm going to do here. If a.is or instance of airplane, I'm going to stall recover, else system.out.println error. So this is one way that you can manually avoid the error by using this instance of airplane. So before we try the typecast, we verify that the underlying object is actually of an airplane type. Now if we clean and rebuild this project and we run it, of course it's going to run correctly. But what if we change the A to an H? So now we're actually pointed to a helicopter object. Clean and build. Going to run it. and we get our error message at the bottom. So the instance of operator will allow us to avoid these class cast exceptions if we use it correctly. But let me go back to A. Now, before we end today's demonstration, I want to show you a third way, or really a second way, of implementing an interface. An interface, so recall from the lecture that there's no such thing as an actual object of the flyable type. So if I try to write flyable u equals new flyable, we're going to get an error. And the error says flyable's abstract cannot be instantiated. So an interface, remember, is not a class. We cannot create an object of the interface type. We can only create an object of a class type where the class implements the interface. Now, so we see we can't create an object of type flyable. However, what we can do is we can create what's called an anonymous class. Now, this is not in the lecture. This is a little bit different, and it's used a lot throughout Java. And it's usually used when writing a very, very simple class that implements a very simple interface. You can create an inline class that implements the interface. So let me show you how you do that. Now, it looks like you're creating an object of type flyable, but instead of calling a constructor, I'm going to do something very interesting. I'm going to act as if I'm calling a constructor for flyable, but then I'm going to add a body with braces right after it. And this will define what's called an anonymous class. These two braces are now defining a class. Just like we create any other class, this is an anonymous class that we're defining within our flyable tester. So it's a local class, and it's in particular an anonymous class because it doesn't have a name. Now, ultimately, it's going to be given a name by the Java compiler, and it will create a class file for this anonymous class with some weird name to it, which we don't need to worry about. But for our purposes, it doesn't have a name. It's an anonymous class whose use has very limited scope. In this case, it'll just exist within this main method. So we're creating a new flyable object type through an anonymous class. It has to implement the flyable interface, which means we have to provide implementations for the two methods in flyable. We're going to make this a UFO class, an unidentified flying object. So we're going to implement the methods just like we would in any other class. Public, void, takeoff. The UFO is taking off. Oh, sorry. Can't do that. What am I doing here? This is what happens. Try to rush through things. Let's do system.out.println. The UFO is taking off. Forgot my parentheses there. I'm going to need a semicolon at the very end of all this. And we need to provide a method for yield way2, public void. We can also add an @override annotation. @override public void yield way to flyable f. In this case, we're not even going to use the flyable f references. Our implementation for yield way to will be very simple. System.out.println UFOs don't yield the way lastly, let's put an override to toString. You can always create objects in this way, by the way. You don't have to necessarily be creating an interface. You can create a subclass of object you can say object obj equals new object, and then in braces immediately start defining an anonymous class, which would become an anonymous subclass of object, or any other subclass later on when we get into superclasses and subclasses. So the toString method is going to return a UFO. It doesn't have a tail number or anything. Or the UFO. Alright, so here's our anonymous class. We don't have any errors left here. I think I have an extra brace though, so let's get rid of that. Let's make the UFO take off. Let's get rid of the stall recover. Well, we can put that at the end. Let's make the helicopter yield the way to the UFO. And let's try to make the UFO yield the way to the airplane. So we added a few more instructions just so we can demo the use of our anonymous UFO class. We're going to make the UFO take off after the airplane and the helicopter. The airplane is going to yield the way to the helicopter and then stall recover. The helicopter is going to yield the way to the UFO, and then the UFO is going to, and I say this in quotes, yield the way to the airplane. Let's see what happens. We're going to go to Run, Clean Build Project, go back to Run. Let's run the project and see what happens. Airplane November 1, 2, 3, 4 is taking off. Then helicopter November 5, 6, 7, 8 is taking off vertically. Then the UFO is taking off. Then airplane November 1, 2, 3, 4 is slowing down and yielding the way to helicopter November 5, 6, 7, 8. Then we have November 1, 2, 3, 4 is recovering from a stall. That's correct. Then we have helicopter November 5, 6, 7, 8 is slowing down to a hover in order to avoid the UFO. And lastly, when we ask the UFO, when air traffic control asks the UFO to yield the way to the airplane, the UFO responds by writing, UFOs don't yield the way to anyone. Okay, so there you have it. In this demo, we created an interface called Flyable, which lists a set of commands that any kind of flying object type should be able to implement. And then we provided 3 classes that implement the interface, including airplane, helicopter, and an anonymous class to represent the concept of a UFO. So that's all there is for now. I'm going to post the code for this demo shortly, and I would highly recommend that you look at it and maybe try to do your own examples with interfaces. If you don't do your own examples, you'll be getting a homework assignment where you'll have to use interfaces anyway. So one way or the other, you need to get comfortable with interfaces in order to be a strong Java programmer. If you have any questions, remember, I love to get emails. Please send me an email. I'll be happy to answer your questions. All right, take care, and I will see you all next week.